check. Check. Screen black இருக்கா? Yeah, now it's fine. Hello everyone. Hello people. Right, voice நல்லா கேக்குது, பார்த்து செக் பண்ணிட்டேன். I'll try to be loud as few people suggested in last class la. Okay. Hello. If everything was clear, okay, audible, visible, chat la ஒரு thumbs up பண்ண போடுங்க. And then as usual, NEET 2026, we have few days left only. As usual, our 15 minutes we'll talk about your preparation எப்படி போயிட்டு இருக்குன்னு. Okay, hi Safura. This chapter is pretty simple. Okay, I mean, I've combined atoms and nuclei மொத்த ஒட்டுக்கா. Okay, அண்ணா உங்களுக்கு லீவ் இல்லையா? அண்ணா லீவ் இல்லை இன்னைக்கு. காலைல போஸ்டிங்ஸ் போயிட்டு ஆஃப்டர்நூன் ஒரு கிளாஸ் போயிட்டு ஐ கேம் பேக். இன்னும் 3 கிளாஸ் இருக்குது, அட்டென்ட் பண்ணல. நான் இன்னைக்கு அதை முடிக்கணும். And then ஈவினிங் இன்னொரு கிளாஸ் இருக்குது. ஈவினிங் வந்து மேக்னடிசம் அண்ட் மேட்டர். ஓகே, தட்ஸ் ஃபுல் ஆன் தியரிட்டிக்கல் சாப்டர். அதுக்கு வந்து ஐ எக்ஸ்பிளைன் இட் இன் audible. Okay, nice. Fine. Okay, இன்னும் வந்து how many days do you have? 24 days. Correct, if I'm not wrong. 23 days, including the day of examination. Fine. Okay, audible. Okay, you don't have any doubts அப்போ உங்களுக்கு வந்து I think your 23 days fine. Okay, 23 days இருக்கு. Are you guys stressed? How are you guys all feeling? 23 நாள்ல you're writing an exam which decides how your life goes for the next couple of years. And obviously, if it goes on well, it changes the entire trajectory of whatever you are trying to do. If it doesn't go well, also you will be good at one point. Like you would have. It's just another step in your life. Okay, இது ஒரு சின்ன விஷயம் தான் NEET examination. There is a lot more than whatever this exam is. Okay, but still, it is a way for you. I mean, if you clear it now, you'll get into a medical college, and then your life would be in that stream. இல்லைனாலும் you would get into something else, and if you really like it and if you're passionate about anything, you could be successful, right? You could be successful in any field if you like them, and if you are passionate about it. So it's not a life deciding exam, but still it's an exam which is a major part of your life. And other part, are you guys stressed, or how is it? How is everything இப்போ? Hmm. Right, it's my a major part of your life. It decides ஓரளவுக்கு நீங்க என்ன பண்ண போறீங்கன்னு. ஓ, forgetting few concepts in exam marks drop ஆகுது. Safura. Okay, tell me, is it because of the time constraint pressure, or is it because you haven't revised it for a while? You haven't touched on the concept கொஞ்ச நாளைக்கு முன்னாடி, or உன்னால exam pressure ஆல you're not able to solve, you're forgetting stuff. If it were exam stress I would say practice more. If you haven't revised it in a while, அதனால நீங்க மறக்கறீங்கன்னா கான்செப்ட், தயவு செஞ்சு படிங்க. Okay, few, but I remember them during analysis. Yeah, exactly. That means it's because of your exam thing. Okay, exam pressure தான். Fine. கொஷின் வந்து எக்ஸாமில் சால்வ் பண்ண முடியாது. அதே கொஷின் when you come to எரர் கரெக்ஷன் அப்போ you will be able to solve it. ஏன்னா ஒன்று, it's more than an exam which focuses on solving stuff. It's a race against time. In the entire, it's constructed in such a way that we have to fight, we have to battle with our the time, the clock. Okay, அது கூட போராடி எல்லா கொஷினும் சால்வ் பண்ணும். That's how this exam is. That's how it will get. Okay, once you enter into this medical field, so it's in such a way. Fine. How to solve tough questions even though I know all the formulas வந்து many people could by heart it. Okay, அந்த ஃபார்முலாவை எப்படி அப்ளை பண்ணணும், if you know, you will be able to solve questions. Application of formulas requires concept, okay, as a predisposing factor. So if you don't have a clear idea of what concept it is, and you simply know the formula, there is no use in actually studying physics. Simple question வந்து மாஸ் கொடுத்துருவான், வெலாசிட்டி கொடுத்துருவான், you can find momentum easy. If it had an electron moving through a cyclotron இருக்கட்டும், and then it gets ejected, அதோட in final velocity கண்டுபிடிச்சு eject ஆகும்போது momentum கண்டுபிடிக்கிறது, accelerate எவ்வளோ ஆச்சு. When you get into a stuff which where concepts coincide. Actually they're all related, and எல்லா கான்செப்டையும் ரிலேட் பண்ணி ஒரு கொஷின் வந்துச்சுன்னா people find it tough if that's what you're calling it. Or tough questions may be those questions which have a lengthier solution where the steps are long. அதுலயும் same, you have multiple concepts being applied. Multiple concepts apply ஆச்சுன்னா that means you must have an idea, a good understanding of each individual concept. Fine, அது என்ன போதும். For byte W6Y. Okay. Yeah, I think. And how to do error analysis in a proper way? Okay, fine. Error analysis. Still 24 days இருக்கு. 23 days. That's what. Yeah, that's what Safura said. Okay, 23 days இருக்கு. Okay. Every day write a test. Okay. After writing a test, நீங்க mistake பண்ணிருப்பீங்க. Okay. These mistakes can be either a calculation mistake. So you know the concept, you know how it is. Calculation mistake பண்ணிருக்கலாம். So the numerical, I mean the value of the answer gets changed. 1. 2, எல்லாமே ஒரே மேக்னிடியூட்ல இருக்கும். the dimensions மட்டும் மாறி இருக்கும். ஓகே, இட் கேன் பி நியூட்டன் மீட்டர் ஸ்கொயராக இருந்து நியூட்டன் பை மீட்டர் ஸ்கொயர் இருந்து நியூட்டன் மீட்டர் கியூபாக ஒரு ஆப்ஷன் கூட நியூட்டன் மீட்டர் ஒன்று இருக்கும். ஸோ அதை நீங்கள் பார்க்காம விட்டுருக்கலாம். தட்ஸ் யார் கேர்லெஸ். ஓகே ஃபைன், அந்த மாதிரி மிஸ்டேக்ஸ் இருக்கலாம். திஸ் இஸ் ஆல் த பாசிபிள் மிஸ்டேக்ஸ் ஐம் டெல்லிங் யூ. 3, உனக்கு ஒரு கொஷின் தெரியாமல் இருக்கலாம், ஆனால் சும்மா எதாவது எழுதலான்ட்டு யூ would have shaded it and it would have been right. According to me, அதுவும் மிஸ்டேக் தான். ஓகே, யூ மஸ்ட் நோ ஹவு டு டூ ஹவு டு சால்வ் கொஷின்ஸ். அப்போ தான் அப்போ தான் you can be right. If you are not sure about how you got there, I don't think you have clear idea of what it is. அப்போனா it comes under a mistake தான். ஓகே, you have to consider that as well. ஃபைன். அதுக்கப்புறம் சில கொஷின் நீ அன்அட்டெம்ப்டில் வச்சுருக்க, அன்அட்டெம்ப்டடில், that those questions also come under these. And then ஒரு கொஷின் படித்து உனக்கு கான்செப்டே தெரில, அந்த மாதிரி கொஷினையும் comes under mistakes. ஓகே, all these things. இதில் வந்து கேல்குலேஷன் மிஸ்டேக், டைமென்ஷன் பார்க்காத மிஸ்டேக், இதெல்லாம் சும்மா சிம்பிளாக ஒரு நோட்டில் யூ கேன் சிம்பிளி ரைட் த கேல்குலேஷன் மிஸ்டேக் பிகாஸ் அண்ட் யூ கேன் calculate it again அந்த நோட்லேயே, பிகாஸ் தட்ஸ் வாட் ஐ டிட். ஓகே, திஸ் இஸ் வாட் ஐ எம் வாட் எவர் ஐ எம் டெலிங் யூ இஸ் வாட் ஐ டிட் டியூரிங் மை எரர் அனாலிசிஸ். ரைட் இட் டவுன். ஃபைன், முடிஞ்சு. இதுக்கப்புறம் த நெக்ஸ்ட் செட் ஆஃப் கொஷின் நீ அப்படியே போயிட்டே இருப்பேன். ஓ, திஸ் கான்செப்டே எனக்கு தெரியல. வாட் யூ டூ, ட்ரை சால்விங் தட் கொஷின். ஓகே, try solving the question with whatever you have already studied. முடியல, அந்த கேஸ் leave that question, go study the concept whatever it is. Okay, study it and solve it again so that you won't forget it. Okay, நீ வந்து எவ்வளோக்கு எவ்வளோ இந்த மாதிரி அப்ரோச்சில் போறியோ, having proper practice rather than looking at solutions, the more the concepts will retain in your mind and you will be able to reproduce the exact same thing in the exam if they ask it. Okay, it's actually really helpful. Fine, concept படிச்சு you write the solution, அதுக்கப்புறம் you try to solve it and then you finish your that question and move on to the next one. அண்ட் அன்அட்டெம்ப்டட், ஓகே, உங்களுக்கு தெரிஞ்சிருந்தா நீங்கள் அப்படியே சால்வ் பண்ணலாம். அன்அட்டெம்ப்டடில் உங்களுக்கு தெரியலனா அந்த கொஷின்ஸ் அகெயின் ரீட் தி கான்செப்ட், டூ சால்வ் த கொஷின். ஃபைன், திஸ் இஸ் ஹவ் தி அப்ரோச் ஃபார் ஃபிசிக்ஸ் இட் ஷுட் பி. அந்த எல்லாமே தெரியாத ஐ மீன் ஃப்ளூக்கில் அடித்த கொஷின்லாம் வந்து திருப்பி யூ ஹாவ் டு சால்வ் இட் ப்ராப்பர்லி. ரைட், பிகாஸ் எக்ஸாம் எழுதும்போது உங்களுக்கு ஒரு கம்ப்ளீட் ஐடியா ஆஃப் தி கொஷின் பேப்பர் இல்லாமல் இருக்கலாம். But after the examination, you must have a complete in-depth knowledge about whatever they have asked in that examination. அந்த எக்ஸாமில் இருக்கிற எல்லா கொஷின்ஸோட எல்லா ஃபவுண்டேஷன் கான்செப்ட்ஸ்லையும் யூ மஸ்ட் பி ஸ்ட்ராங் ஆஃப்டர் தி எக்ஸாமினேஷன். தட்ஸ் வாட் gets you better every day. It gets you little by little, konja konjama you'll reduce your mistakes, konja konjama you'll improve your marks, and then finally you go write your NEET exam. Avladhan. Okay. Anything else? And then we'll start the class. Few more questions. The chapter is easy, very simple now. I'll finish it in like 1.5 hours to 2 hours. Okay, it's the concepts வந்து சின்னதான். ஓகே, ஆட்டம்ஸாக இருக்கட்டும், ஆட்டம்ஸ் என்டையர் திங் நீங்கள் அட்டாமிக் ஸ்ட்ரக்சரில் படிச்சிருப்பீங்க. அட்டாமிக் ஸ்ட்ரக்சர் ஆஃப் கெமிஸ்ட்ரி includes atoms of ஒரு part of physics obviously. கொஞ்சமாக நியூக்ளியஸோடது, கொஞ்சமாக நியூக்ளியஸ் they won't ask அவ்வளோவா பெருசு all depth. And then you have what is that chapter, bro? I think dual nature of radiation and matter. அது கொஞ்சம். And then chemistry part, obviously orbitals and all that. So when you have an idea of chemistry atoms, okay, chemistry atoms ஒரு ஐடியா இருந்துச்சுன்னா physics எழுதலாம். ஓகே, சேம் thermodynamics, chemistry thermodynamicsக்கு ஒரு நல்ல ஒரு அண்டர்ஸ்டாண்டிங் இருந்துச்சுன்னா, பிகாஸ் இட்ஸ் மோர் இன்டெப்த். யூ ஹாவ் என்ட்ரோபி கான்செப்ட்லாம் அதில் இருக்கும். யூ டோன்ட் ஹாவ் தட் இன் ஃபிசிக்ஸ். ஓகே, ஐ மீன் யூ டோன்ட் ஹாவ் இட் இன் யோர் ஃபிசிக்ஸ் 11th standard. ஓகே, but 11th chemistry it's there. Fine, shall I start the class up then? And also 24 days, if you feel like you're not having enough question papers, okay, to solve, we have our SNG app test series, okay, exclusively for NEET 2026 question paper standard for physics. நான் எடுத்தேன். I took it in the best way possible. Say NEET 2025 அளவுக்கு டஃப்பான கொஷின்ஸும் இருக்குது. There are moderate questions, there are easier questions. It's a mix of everything, but the questions are not too easy, so that ஒரே லைன் அப்படியே சால்வ் பண்ணிட்டு போகலான்ட்டு. Fine, I've made sure that questions are not repeated as well. I mean similar concept questions. Okay, fine. நிறைய ஸ்டேட்மெண்ட் பேஸ்ட் கொஷின்ஸ் இருக்கும். ஓகே, it will be really helpful. Fine, go check it out. And then this is Vidamuyarchi 2.0 for you guys, and I am Rehan from Madras Medical College, studying second year MBBS. And here to take atomic and nuclear physics. Okay, fine. Okay, now okay, I have a doubt. I don't know whom to ask. For NEET, should we cover each and every concept or study in a smart way? We will talk here. See, the idea was to be prepared for the worst case. Okay, randomly book-oda or ஏதோ ஒரு மூலையில இருந்து if they ask a question, we should be able to answer it. That's how we all prepared. Okay, அந்த மாதிரி ஆன்சர் பண்ண, that's the only that could be the only difference. Okay, for you and someone who had been scoring the entire series, test series-லே one level score பண்ணியிருப்பான். But then there would be so many people writing as well. Okay, ஒரு questionல hundreds and even 1000 rank மாறும். ஓகே, ஒரு கொஷினில். ஃபார் மீ இட் வாஸ் இன் தட் வே. ஒரு கொஷின் எடுத்தோடனே ஐ லாஸ்ட் 1000 rank, 1500 something. ஓகே, ஸோ தட் ஒரு கொஷினால் யூ குட் கெட் இன் டு your dream college. That ஒரு questionனால you'll have something in later. Okay, so that was the only thing. So we had prepared everything. எல்லா கான்செப்டும் படிச்சோம். But studying in a smart way, I don't know what you mean by studying in a smart way. நீங்கள் படிக்கிறதே, if you study everything and then revise it, I think that's enough. Smart way na simply solving questions in சொல்ல வரீங்களா Safura? I don't get it. But yeah, we did read every concept. Fine. எல்லா கான்செப்டும் படிச்சோம் தான். Because ஒரு கொஷினில் கூட we can miss so many colleges. Okay, ஒரு கொஷினில் 4 marks. Okay, a matter of 4 marks தான். That could be the only differentiating point between you and someone else. Because you read that particular line in the corner of the book. Okay, adala you got this seat. Fine. That I think that makes sense. That makes total sense. And also, can you specify what do you mean by studying in a smart way too? Yeah, I think I'll start the class. Let's not talk about that, Laksh. If you want, DM me personally. Okay. Okay. In the chapter, it's all theoretical. It's a little too much theoretical. Fine. First, we'll study what atoms are. Okay. And then nucleus in our half an hour I'll finish it. It's simple. Okay. Nucleus chapter la ஒன்றும் இல்லை. You have what are nucleons, protons and neutrons. அது என்னது, and mass relation, radius. Okay, அவ்வளோ இருக்கும். Then nuclear force ன்னு ஒரு கான்செப்ட் இருக்கும். After nuclear force you'll have fission fusion reactions. அவ்வளோதான், முடிஞ்சு. Chapter done. Binding energy, I think அதுக்கு மேலே ஒன்றும் இல்லைன்னு நினைக்கிறேன். இதில் தான் கொஞ்சம் அதிகமாக இருக்குது. Nuclei have constituent, size of nucleus, density obviously, mass energy relation, binding energy, mass deficit, yeah, nuclear force, stability of nucleus, fission fusion reactions, all of them. It's a very simple chapter. Okay, we'll get into atomic structure. Safura, tell me what do you mean by studying in a smart way too. Okay. Fine. Atomic structure, இதை வந்து நீங்கள் கெமிஸ்ட்ரியில் படிச்சிட்டிங்கன்னா they'll be like அணு பரமாணுன்னு எல்லாம் ஆதி காலத்தில் சொல்லியிருந்தாங்க அப்படின்ட்டு. there would be statements in the book. Basically atoms-னு ஒன்று இருக்குது. We have few tiny fundamental particles which make up the entire universe-னு பீப்புளுக்கு ஒரு ஐடியா இருந்துச்சு. Like they had this idea for so long, from 500 BC. There have been statements at very, like, focusing on heavy weighted chapters, some questions which are frequently asked and leaving chapters. No, we didn't do that. Okay, focusing on heavy weighted chapters, no. They don't ask a lot of questions from few chapters, but still on the chapter we did revise. say the biodiversity chapter la, there are percentages, okay va? There are graphs, and then there are percentages of every species oda எவ்வளோ எவ்வளோ இங்கே they are habited, I mean they are present in every different locations அந்த மாதிரிலாம் percentage இருக்கு. We were sure that they won't ask, okay? A lot of us were sure that they won't ask percentage, they won't ask numerical based questions. Maybe pie chart ல கேட்பானா pie chart கேட்டாங்க எங்களுக்கு, fine, but still we everybody by heart they knew whatever those percentages were, okay? Because in case கேட்டாங்கன்னா that will be the only differentiating point between us and someone else getting a seat in our dream college. Fine, keeping that in mind, we focus on almost everything, even the for 11th standard and the scientist பத்தி இருக்கும். I studied that as well. It's not necessary, but still we did study. It's, yeah, preparing for the worst case is never going to waste. Okay, fine, all right. Okay, atomic structure இந்த மாதிரி ரொம்ப நாளா இந்த மாதிரி பேச்சு போயிட்டு இருந்துச்சு, that something like this exists, something super tiny exists, which makes up our entire universe அப்படின்ட்டு. ஓகேவா, fine. Okay, fine. Okay, atomic structure என்ன ஆச்சுன்னா, ஸோ இது சொல்லிட்டேன். ஓகே, ஃபைன். இப்போ சப்அட்டாமிக் பார்ட்டிகல்ஸ், திஸ் கொஷின், இது வேணால் கொஷின் வரலாம். ஓகே, சப்அட்டாமிக் பார்ட்டிகல்ஸ் யார் எந்தெந்த சப்அட்டாமிக் பார்ட்டிகல்ஸ் கண்டுபிடிச்சான்ட்டு ஒரு மேத்ஸ் த ஃபாலோயிங் கேட்க வாய்ப்பு இருக்குது. ஓகே, ஃபிசிக்ஸில் கேட்கக்கூடாது, தியரி பேஸ்ட் கொஷின்ஸ், சயின்டிஸ்ட் பேஸ்ட் கொஷின்ஸ் கேட்டாங்கன்னா, அந்த எக்ஸாம் ஹாலில் கேட்டாங்கன்னா we can't go to court அப்போது. ஓகே, we can't say they aren't supposed to ask, they have asked already. Okay, we must be prepared for it, அவ்வளோதான். Okay, don't take it as a burden guys, studying everything. Okay, discovery of subatomic particles. Electron was discovered by யாரு? J.J. Thomson. Proton was discovered by Rutherford. And who did discover my neutron? James Chadwick. இது மட்டும் பார்த்து வச்சுக்கோங்க பேர், இன்கேஸ் கேட்டாங்கன்னா மேத்ஸ் த ஃபாலோயிங்கில் யூ மஸ்ட் பி ஏபிள் டு ஆன்சர். ஓகே, might be asked match the following. Okay, படிச்சு வச்சுக்கோங்க. ஓகே, ஸோ ஜஸ்ட் நோ. ஓகே, ஜேஜே தாம்சன், ரூதர்ஃபோர்ட் எல்லாம் ஞாபகம் இருக்கும், சாட்விக் மட்டும் தெரிஞ்சு வச்சுக்கோங்க பேர் புதுசாக. Yeah, my pleasure. Okay. 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 Ipo we know there were talks going on that something was small, something tiny made up our universe. This was the fundamental particle. Okay, அதை வந்து they called atom. Okay, fine. Dalton's theory. There are so many theories about how an atom was. Okay, how an atom was, and there were many theories. Dalton oda theory வந்து he stated that all matter. Okay, இது வந்து I can't write it down, இதனால கேட்டுக்கோங்க. Okay, his theory was that எல்லா மேட்டரும் they were made up of, okay, everything around us was made up of tiny indivisible particles called as atoms. These indivisible particles, okay, நான் எழுதிடுறேன். His statements were, ஏன்னா இது ஸ்டேட்மெண்ட் பேஸ் கொஸ்டின் கேட்கலாம். They were made up of tiny indivisible particles called as atoms. Okay, these indivisible particles, they have of, okay, of specific element were identical. He's not right, he's not wrong in this statement. Okay, were identical, but in the term indivisible particles, this is wrong. Atoms are made up of protons, electrons, neutrons, and there are so many subatomic particles as well. And if you get into a proton or a neutron or an electron, they're made up of quarks. Okay, they're even tiny. Okay, they all make up an atom. Make up the subatomic particles of electron, neutron, proton. Fine. Okay, specific elements or atoms were identical in sonar. What else did he say? They combined in fixed whole numbers to form what are compounds. Okay, fine. They are rearranged in chemical reaction. Okay, fine. These were his postulates for அளவுக்கு idea. Fine, but his theory was wrong. ஏன்னா, just give me a minute. It's a little too cold. Thank you. Fine. Okay, his theory was this. Okay, but then atoms were indivisible. Okay, they weren't indivisible. It had some subatomic particles as well. In the subatomic particles, after their discovery we figured it out that Dalton's theory was wrong. Fine. Okay, we get into Thomson's model. What Thomson said was basically atom இருக்கா, electron, because say after whatever Dalton said, அதுக்கப்புறம் பார்த்தா we discovered all the three subatomic particles. Okay, proton, electron and neutron. So he was like atoms வந்து ஒரு watermelon arrangement சொன்னார். What is a watermelon arrangement? Okay. A watermelon la how seeds are அந்த மாதிரி அரேஞ்ச் இருக்குன்ட்டு சொன்னார். Okay. He was like the seeds were electron positive. ஓகே, என்ன சொன்னார்னா பாசிட்டிவ் சார்ஜ் இருக்கும். ஓகே, நிறைய பாசிட்டிவ் சார்ஜ் இருக்கும், ரேண்டமாக அரேஞ்ச் ஆகிருக்கும். அண்ட் தென் தேர் வேர் நெகட்டிவ் சார்ஜஸ் as well. எலக்ட்ரான்ஸ் சும்மா இந்த ரேண்டம் ஃபேஷன் இந்த மாதிரி அரேஞ்ச் ஆகிருக்கும்ன்ட்டு தாம்சன் சொன்னார். ஓகே ஃபைன். ஸோ இப்போ இங்கே பார்த்தீங்கன்னா அக்கார்டிங் டு ஹிம் இப்போ இந்த செக்மெண்ட்டோட நெட் சார்ஜ் if I see net charge is 0. Fine. If net charge is 0, say I send a charged particle. Okay, idikkitta. Since net charge is 0, it won't have proper attraction, proper repulsion. It will just go undeviated. Fine. Okay. But then Rutherford did an experiment. Okay. Fine. Rutherford did an experiment. Oh my god, screen is black. Just a second. The cable ஏதோ பிரச்சனை guys, ஒரே நிமிஷம். Yeah, it works. Okay. இந்த தாம்சன் பார்த்தோம் இல்லையா, தாம்சனோடது வந்து இஸ் மை ப்ளம் புட்டிங் மாடல்னு சொல்லுவாங்க, ஆர் வாட்டர்மெலன் மாடல். எனிதிங் ஒர்க்ஸ். திஸ் இஸ் வாட் தாம்சன் செட். ஓகே, அவரோட எக்ஸ்பெரிமெண்ட் படி when I send charged particles, everything should go undeviated. But what did Rutherford observe? Rutherford, when he observed, okay, when he sent charged particles through atoms, you can see okay, you can see this particles getting deflected. Okay, some even bounce back. Okay, எப்படி ஃபோக்கஸ் பண்ண, here focusing on the nucleus மட்டும், you can see few particles தூரமா போகுது, they went normal in their own path. Okay, in their original path. And then there are few particles which come close and then get deviated through some angle, and then few particles hit it perpendicularly and bounce back. Okay, fine. This is what Rutherford observed in his famous gold foil experiment. Okay, fine. His experiment, alpha ray scattering experiment. He found out these alpha particles is nothing but helium nucleus. Okay, +2 charged. with mass of 4 atomic units. Alpha particles, they move, mean they deviated from their path. Now, how did he find out this these tiny particles they hit and they deviated? He had a gold screen, I mean gold sheet, very thin because gold is the most malleable metal. Okay, this is also a statement question. So this thin gold sheet was placed and alpha particles essentially hit பண்ண ஆரம்பிச்சார். Okay, the experiment started. uh, and then what happened after alpha particles hit? Okay, some got deflected up. ஆனால் அதை அப்சர்வ் பண்ணுறதுக்கு he had a zinc sulfate screen. Okay, which emits light whenever it hits, it gets excited. Okay, so அந்த மாதிரி ஒரு screen வச்சதுக்கப்புறம் whenever the particles get deflected, they go hit the wall of the screen தொடும்போது there is it eliminates. So அதை வச்சு he was able to find out that there are few particles inside the atom which are charged, and because I mean they are charged because he knew they were charged, but still they are not distributed in this plum pudding cake manner, rather in a way that there is more space in an atom and a positively charged core is at the center with electron revolving around the nucleus. Fine. Clear? But his, okay, இவரோட ஐடியா வந்து he whatever he told was right. He wasn't wrong though. Okay. Okay, what he told was that there is a positively charged core around which negatively charged electrons were revolving in circular paths. Okay, fine. Okay, this is what he told. Okay, fine. And most of the atom was just empty space. Another one, the majority of the alpha particles went undeviated. Fine. Maxwell's law. So no one's having any doubts. Okay, fine. Maxwell's law, we studied. Okay, electromagnetic waves are produced produce electromagnetic waves. Okay, this is very crucial. Just listen. When a particle is moving in a circular motion, won't it have an acceleration of v square by r? A centripetal acceleration. Correct? This v square by r, okay, Co- because of this acceleration there is a loss of energy. Acceleration, there is an emission of EM waves, electromagnetic waves emit anna, there is nothing but loss of energy. When it loses energy, this electron slowly falls into the nucleus of the atom. When it falls into the nucleus of the atom, won't it be similar to this model given by Thomson? Right? Makes total sense. ஏன்னா எலக்ட்ரானுக்கு எனர்ஜி இருக்கு, ஆனால் ஆக்சிலேட் ஆகிறதால when it loses energy, definitely it loses energy, because of which it falls into the nucleus, and then it resembles my Thomson's model. So this is also a failure theory. It was able to tell us that there is a positive score and electron revolve around it, but we don't know how and why. Okay, fine. Hmm. Okay, fine. இது வரையும் clear till this whatever Rutherford told me. ஏன்னா இதுக்கப்புறம் தான் வந்து we'll have expressions and then hydrogen line absorption spectrum. Yeah, இதுக்கப்புறம் we'll just take a small break. Okay, it's a very simple chapter. These two are and question solving வந்து will be exclusively done in a session for question solving. Okay, not today. கொஞ்சமா I'll solve, but still. Okay, fine. Okay guys, so இதுக்கு மேலே I think oh, okay, Safara gave me a thumbs up, so no one else has understood it. Okay, never mind. I still will proceed. This is the most important person in my opinion so far. His works are actually built upon the works of the previous P guys who tried to predict the atomic structure. ஆனால் இப்போ Bohr's model is what it'll make sense. Okay, let's see. Okay, he told us that electrons revolve in a fixed okay, in a fixed energy state. Okay, so that when they move they don't lose energy. When they accelerate, when they go around the atom, yeah, if you ask me why we have to get into quantum physics, it is not necessary as of now. Just remember it's in such a way. It's moving around in a circular direction. எப்பவுமே acceleration இருக்கும் தான். You can argue, but it's not necessary to this level. Okay, fine. It revolves in a fixed energy state. Fixed energy state like it's revolving. Okay, fine. So that it won't lose energy while getting accelerated. Okay, makes total sense. Fine. Okay. Hmm. S- s- These fixed indices are discrete. Okay. Rather, it's a nucleus now. My electron can be either in this energy state or this energy state or this energy state. Nothing in between. Okay. Hmm. So my electron can be in this state, this energy state or this energy state or this energy state, and nothing in between. இதுக்கு நடுவில் எங்குமே இருக்காது. இதுக்கு நடுவில் எங்குமே இருக்காது. Fine. Fine. Okay. This is what Bohr said. Okay. Fine. இந்த postulateல first postulate சொல்லியாச்சு. Second postulate is that for the electron moving in this orbit, okay, the angular momentum L is equal to nh by 2 pi, where n is the orbital number. Fine. எத்தனாவது எனர்ஜி ஸ்டேட்ல இருக்கும். Fine. Okay. இப்போ L என்னது? L is nothing but my angular momentum. இது எப்படி எழுதலாம்? mvr எழுதலாமா? mvr equals to nh by 2 pi. The most equation of this entire chapter. I will even hide this. Okay. Okay, fine. இப்போ பாருங்க, this is a higher energy state, this is a lower energy state. Okay, an electron is here. Say this electron de-excites. When this electron de-excites from here to here, what happens? இது energy குறையுமா? In the decreasing energy will be converted as, will be sent out as light energy. Makes sense. Okay, fine, very clear. So I can write, this is energy level 2, this is energy level 1 now. The energy of photon really emitted is nothing but E2 minus E1. Okay, is equal to h nu, okay. This is the energy of photon. So E2 minus E1 by h is equal to by nu, my frequency of emitted light. Okay, paka. So far clear? Okay, nice. Fine. Okay. Now let's do the exact reverse of whatever we did before. Take the same two different energy states. of energy E1, E2, and then I have an electron here. Okay. இப்போ இந்த எலக்ட்ரான் வந்து நான் இங்கே மேலே கொண்டு போய் வைக்கணும்னா I I I need light. So light hit I, the electron will get into a higher energy state. Fine. The entire process is reverse. When it de-excites, it emits light. When it excites, it takes in light. Fine. These are major postulates. We have okay. We know that MBR equals NH by 2 pi. So R is equal to NH by 2 pi MV. Simple. This is my radius at which where it is present. Okay, this is how I can find another nth orbit order radius. Okay, fine. Okay. This equation is valid. Okay, இதை வந்து நமக்கு அந்த சைடு வச்சுக்கலாம். Fine. We have one more equation. இப்போ electrons are what? They are charged particles, right or not? Am I right or not? Charged particles are electrons, obviously. So what charged particles interact amongst themselves? Obviously they do. Electrons and protons interact through what? Electrical force of attraction. Obviously, okay, wow. This force of attraction should be counted by some other force so that my electron doesn't get attracted to the nucleus and falls into it. Fine. So either the force in K Q1 Q2 divided by R square is equal to my force of attraction is nothing but mv square by R, centrifugal force, mv square divided by R. Fine. Okay, இது clear? K எப்படி எழுதலாம்? 1 by 4 pi epsilon naught Q1 Q2 divided by R is equal to my mv square. Fine. Okay. இப்போ வந்து from using this equation, okay, this equation and this equation, we are going to get something else, something new. Okay, blank sheet. Okay, fine. Wait. Okay. அப்பப்போ I hate this Apple stuff. என்ன navigate பண்ணுறது கொஞ்சம் கஷ்டமாக இருக்குது இல்லை. Okay, fine. Where are I? Fine. We have two equations. MER equals NS by 2 pi. MV square is equal to R. Okay. இது வந்து நான் இப்போ எழுதுறேன். Using these two equations, I am writing down mvr into velocity of electron is equal to 1 by 4 pi epsilon naught into q1 into q2. Okay, fine. Okay, இப்போ MVR என்னது? NH by 2 pi. So NH by 2 pi into velocity is equal to 1 by 4 pi epsilon naught q1 into q2. Fine. q1 q2 என்னது? ஒரு எலக்ட்ரான் into entire positive core. Z into charge of electron into charge of electron. Correct? Correct. Fine. இதை வச்சு we can find relation of H. Velocity of n, not H. We can find velocity of nth orbit is equal to ZE square by 2 epsilon naught H. Okay, correct. It makes total sense. Okay, fine. இப்போ வந்து there are few more equations as well. அதை வந்து you don't have to remember, derive பண்ண தெரியாத பிரச்சனை இல்லை. ஓகேவா? So radius of my nth orbital is equal to n square h square epsilon naught divided by pi m e square. Fine. Okay, my velocity of nth orbital, okay, velocity of nth orbital is nothing but 1 by 4 pi epsilon naught to 2 pi z e square divided by nh. This is what I derived few moments back. Velocity of nth orbital is this. Okay, this is the radius of nth orbital. Radius. Okay, fine. Lovely. Now we'll do something interesting. Too much. இங்க பாத்தீங்கன்னா 1 by 4 pi epsilon naught pi epsilon naught, they're all pi e square, they're all fixed values. Correct? So அதை வச்சு we'll find a shorter term so that we can actually use it in problem solving. This is the most important thing. So for radius of nth orbit is equal to 0.53 into n square by z in angstroms. Angstroms are 10 per minus 10. Okay. This is radius of nth orbit. Fine. But velocity of nth orbit is nothing but velocity padina is related to z, what did I write here, nhr, yeah, z by n. So z by n into or a set of constant values, my fine, into these constant values or some, I mean, Planck's constant, charge of electron, அதெல்லாம் சேர்த்து வரும். கரெக்டா? Fine. Oh, okay, done. This is, so then this will be a proportional constant. Okay, right. Velocity of nth orbital கண்டுபிடிச்சாச்சு, radius of nth orbital கண்டுபிடிச்சாச்சு. Fine. இதுக்கு மேலே what else we have? So we have I think probably the energy. Okay, probably energy. Okay. சரி இங்க பார்த்தீங்கன்னா we would have studied this in கேடிஜி கேடிஜியில் வந்து கைனடிக் எனர்ஜி ப்ளஸ் பொட்டன்ஷியல் எனர்ஜி ஈக்குவல்ஸ் டோட்டல் எனர்ஜி அதில் வந்து we knew potential energy twice potential energy was equal to total energy in terms of numerical value, right? No, two times of they were distributed. Two times of the total energy was in potential energy. My negative one was in kinetic energy. So that's how we had normal value. I mean normal value of this entire thing. Okay, fine. Okay, okay, fine. Now Bohr's இப்போ energy level energy of nth orbital. It's nothing but 13.6 into z square by n square. This is in electron volts. Okay, fine, paka. அவ்வளோதான் இதோட the major thing of this chapter is all done. And then atomic இது spectrum இருக்கு. Spectrum முடிச்சு we'll get a nuclei in a bit. Okay, I think that works. Hydrogen line spectrum. Okay, fine. Absorption and emission spectrum. One நிமிஷம். I think we have it here. ஒரு நிமிஷம். Yeah, I got the image. Fine. Okay, this is what, and this is an absorption spectrum. Okay, absorption spectrum and emission spectrum, they're like two sides of the exact same coin. Okay, fine. Here இங்க இருக்கிறது எல்லாமே வந்து my this is my absorption spectrum. Fine. Okay, fine. Time period, frequency. Okay, fine. Just have a look at here. Okay, hydrogen atom. Okay, wow. Hydrogen atom இருக்கு. Okay, it has energy levels fixed. Okay, wow. each KLMNOP, all these individual levels, they have specific energies mattumda, right? They have specific energies mattumda. They don't have more, they don't have less, they have specific energies. This specific energy difference, okay, will have an emission of a specific radiation. Okay, fine. But a specific radiation will be produced only if the specific, if over a fixed value, and the value of photon on the hit panna mattumda, it will get excited to a level after which when it de-excites, it releases the same value of energy as photon. Fine, makes sense. Okay. இப்போ பார்த்தீங்கன்னா this is the key is my emission spectrum. Okay, this is what my hydrogen atom emits when it gets excited and when it's de-excited again. Okay, fine. The above one is the absorption spectrum. Okay, those are all the frequencies of energy. Okay, the entire visible spectrum la in the line இருக்கு இல்லையா, the missing spots, and the missing spots எல்லாம் தான் வந்து my hydrogen atom absorbed so that it can get excited. அந்த set of frequency மட்டும்தான். And அதே set of frequency தான் வந்து when it gets de-excited, it releases. Fine. This is what an absorption and emission spectrum are. For every individual element, the absorption and emission spectrum are unique. They are very, very unique. Fine. Okay. இதை வச்சு we can find a planet so far away, அதில் என்ன எலிமெண்ட் உள்ளே இருக்குன்ட்டு we can find it out using this reference வச்சு. இங்கே hydrogen spectrum வச்சு we can find that sunல there is hydrogen, sunல there is helium அப்படின்ட்டு we can compare it அதோட absorption and emission spectrum with the ones which we have இங்கே. Okay, all right, fine. So this is what basically hydrogen spectrum is. Okay, hydrogen line spectrum is this is what it is all about. Fine. In the chapter la, the only thing you need to know are this relation, the above one, and this relation. These three things are very important. இதெல்லாம் வந்து மறந்துடுங்க. This is not அவ்வளோ necessary. Okay, fine. Okay, done. ஸோ நான் வந்து ஜிஸ்டில் சொல்லிட்டேன் வாட் எவர் இட் இஸ். இப்போ வந்து let's get a little deeper into how an nth orbit, right, how de-excitation the wavelength will be able to calculate. Okay, அதோட we'll finish the chapter. Now understand, I told you what an absorption, what an emission spectrum are. Okay, fine. Now see here, these are energy levels. Okay, இப்போ இந்த எனர்ஜி லெவல்ல இருந்து if there is a drop, okay, இந்த எனர்ஜி லெவலுக்கு வரும்போது it's de-exciting. Okay, from the third energy level to my first energy level, there is a de-excitation of this electron. When there is such de-excitation, what will be the frequency of the light produced? What will be the frequency? Simply change in energy, difference in energy. E3 இருக்கும், இங்கே ஒரு எனர்ஜி இருக்கும், இங்கே ஒரு எனர்ஜி லெவல் இருக்கும். ஸோ E3 minus E1 divided by Planck's constant h gives me my frequency. Correct? This is basically what we are going to find. Okay. Right. இப்போ வந்து Now we know energy of individual atom oda individual orbital level la. This is the energy, okay, for it's minus 13.6 into z square by n square. Okay, since it belongs to the exact same atom, we can take z square common veliya, so it's 13.6 into z square by into 1 by n1 square minus 1 by n2 square. Okay, this is what gives me my this will give me the energy difference. Either divided by my h gives me my frequency. Okay, is clear? Just know, because of attractive forces, the energy of this nth orbital is minus. Okay, wow, this is minus. Okay, just so you know. Clear? All right. Okay, fine. This is the, don't get confused, this is the total energy. Okay, total energy order 2 times magnitude will be my potential energy, minus 1 times I'll have my kinetic energy. Fine. So if my hydrogen atom order first orbital had minus 13.6, first orbital is an electron had minus 13.6 electron volts of energy. Now the potential energy of that atom, I mean, is 20 minus 24.2. Okay, and the kinetic energy it possesses is plus 13.6. Okay, fine. So I'll write it down so that it makes sense. Ke is equal to minus Te. Pe is equal to 2 times the flow energy. Yeah, I hope this makes sense. Fine. Okay. So all right. So we got this. So there is no way they can ask questions from this chapter, right? Okay. Okay. After this, okay, after this chapter majorly deals with Bohr matunda. Niels Bohr. Okay, and one more thing I forgot. There are series. Okay, series called as Lehman, Balmer, Passion, Bracket, and Fund series. Okay, so I say there are so many levels of excitation. Okay, wow. No matter from where it comes. Okay, if it falls on either of these, in the answer line, 1 2 3 4 5. Okay, let's remove one. Bracket discuss பண்ணிட்டோம். Okay, இப்போ say from anywhere there is de-excitation to the ground level. Okay, this includes my Lyman series. Sorry, Lyman series. Know, from any excited state to my ground state, to my first energy level, when electrons de-excite, they produce a set of lines, the set of characteristic spectra here. I mean, இந்த மாதிரி they emit. Okay, wow. This emission is not a single frequency, it's a thing, uh, it's a spectrum to some extent. Okay, fine. All these lines, they belong to Lyman series. Okay, அதே வந்து from anywhere if they de-excite to my second from anywhere, bro, basically. Okay, second constant is called as my Balmer series. அப்புறம் என்ன அர்த்தம்? If they mention Balmer series in your question paper, அப்போனா உன்னோட N2 value is what? 2. If they include Lyman series in your question paper, அப்போ உன்னோட N2 value is 1. Okay, and then you have Passion series. Okay, Passion series. Okay, and then you have Fund. Passion bracket, this is my Passion series. இது எல்லாருக்கும் தெரியும். Okay, இப்போ if they ask Lyman seriesல first line and bracket, okay, first line ஓட frequency என்ன கேட்குறாங்கன்னா, you use this formula to find frequency. Simple. Okay. Or you could even simplify this into little more that. So you have 13.6 into z square and this entire thing 1 by n1 square minus 1 by n2 square. Okay, fine. இதுல இருந்து this is equal to my energy, which is nothing but hc by lambda. Correcta? Okay, hc நான் இங்க கீழே கொண்டு வந்துட்டேனா, hc இதை இங்கே கொண்டு வந்துடுறேன். Okay, so it will be 13.6 divided by h into c into z square into 1 by n1 square minus 1 by n2 square. Correcta? Fine. இப்போ இதை வந்து they call it a constant. Okay, it's called as the Rydberg's constant. This is my Rydberg's constant. So this is equal to my 1 by lambda or my wave number. This is my wave number. அதாவது 1 by wavelength is nothing but my wave number. Okay, I hope everyone knows this. Potential energy equals to minus 2 ke. Yeah, basically exactly the same thing. Fine. ஏன்னா நான் இங்கே என்ன போட்டிருந்தேன் சஃபரா, I wrote that potential energy is equal to 2 times of total energy and kinetic energy was equal to minus total energy. So whatever you wrote was perfectly right. Okay, fine. This is my Rydberg's constant and அதோட value is some, they won't ask பெருசா, but still remember its value goes like I think it's 10.97 into 10 power 3 minus 8 plus I think 10 power 6 or 7 6 10 power 6, yeah, 10 power 6 meters. I mean it's in meter inverse, so it's meter inverse, yeah. Mm. Lambda 1 by lambda இருக்கு. So this is my Rydberg's constant or value. Okay, done, paka. So இதுக்கு மேல I don't think this chapter requires any more stuff. If you want question solving session labo I'll solve questions there, definitely, don't worry. Let's take a break for 10 minutes. Okay, 7 minutes. 7 minutes works. It's 3:13 now. 3:20 we'll start our nuclear chapter. Okay, fine. I'll be back in like 5 minutes. Okay. Have a snack or something. Nuclear chapter easy முடிச்சிடலாம், don't worry. It's pretty simple now. Okay, fine. See you. Hello, hello, hello. It's 23. Okay. In the class maximum, you 40 minutes la mudichalam. It's very simple. Nuclei chapter. It's a very simple, beautiful chapter. Okay. Yeah. Question solving. Okay, don't worry. I have 4 dedicated sessions just for question solving. I'll include as many questions as possible from those chapters. கடைசியா நான் ஒரு last போன class I included 2 chapters. In the class I'm including 2 chapters. அதனால question solve பண்ண டைம் பத்தாதுன்னு நான் விட்டுட்டேன். So I'll try to have them covered up. Okay, don't worry. Fine. Okay. Cool. Nuclei. Okay, we saw what an atom was. An atom included everything. Okay, protons, electrons, neutrons, and all other subatomic particles as well. Fine. Okay, so in the atom nuclear, this nuclei is base pani we are going with this what we're going to study now. Okay, fine. What are the constituents of nucleus of a nucleus? It has protons and it has neutrons. Okay, together they are called as nucleons. They called as nucleons. Why are they called nucleons? Because they constitute the nucleus. Okay, fine. Let's not get into all this. I'll tell you what is required for NEET. Okay, fine. These are the constituents of our nucleus. Okay, size of nucleus. Fine. Size of nucleus. Nucleus is very small. Okay, atom, we know that it is major. One minute before I'll open the chat here. It's closed. Okay, fine. It's majorly tiny. Okay, it's atom is full of space. Okay, it is concentrated, small, and all. Fine. Okay, we know that's how our nucleus is. It's very small. It's in the center. It consists of so many particles. Okay, it consists of neutrons and electrons. I mean neutrons and protons. Okay, fine. Now we are supposed to find the size of nucleus. Nucleus, clear? Nucleus is என்ன protons and neutrons. I am not repeating this. I'm gonna repeat this again, but still, these neutrons and protons, as the atomic, as we go through the periodic table, the atomic number is determined by the number of protons. Okay, fine. This makes perfect sense. Okay, when we go through atoms, okay, when we go through the periodic table, the number of electrons, number of protons get added up. Okay, as they get added up, won't the size of nucleus increase or decrease? Just let me know. As we progress, would the size of nucleus increase or decrease? it will definitely increase. Okay, wow. Fine. It is observed that nucleus or radius radius increases to the cube root of the atomic mass. Okay, so basically my radius of nucleus will be equal to r naught into a power 1 by 3. Okay, r naught value is nothing but my 1.2 into 10 power minus 1.2 into 10 power minus 15 meters. Okay, 10 power minus 15 meters. Okay, so it's in the range of Fermi, right? Fermi da minus 15 range இருக்கும். Pico is minus 9. Okay, fine. This is the size of a nucleus. Okay, fine. Even nucleus or density. Density is nothing but mass by volume. Fine. Nucleus or mass is determined by mass of protons and mass of electrons. I mean mass of protons and mass of neutrons, which is nothing but mass of protons, and they're almost same now. Okay, so we'll take that to be their A is their mass number into mass of proton வச்சுக்கோங்க by volume is nothing but my 4 by 3 pi r cube, where r cube is nothing but r naught into a power 1 by into a r naught into a. Okay, clear? என்ன இங்கே எழுதியிருக்கேன்னா, so if r is equal to r naught a power 1 by 3, so r cube will be equal to r naught cube into a, so it's r naught cube here. Fine. Okay, fine. This itself is atomic mass tha, so I don't think it's necessary here. Fine. So atomic mass and atomic mass get cancelled. Fine. Okay, so if you see here, the density of my atom, I mean of my nucleus, is constant throughout. So every single nucleus will have constant density, but as mass progresses, volume increases in such a ratio that my density remains constant. Fine. Okay, mass energy radiation. இப்போ நீங்கள் பார்த்தீங்கன்னா நியூக்ளியஸ் இருக்கு இல்லையா, நியூக்ளியஸ் if you take in general, if you take mass of the nucleus, okay, சும்மா mass of the nucleus நீங்கள் எடுத்துட்டு, and then when you compare it with individual particle mass or sum, okay, there is a difference. Okay, there's a difference in mass. Okay, there's actually lesser mass in the nucleus compared to that of individual particles or sum. Okay, fine. That deficit of mass is called as my that's mass deficit. Okay, that there is some mass which has reduced. This reduced mass goes and gets converted. It somewhere it has to go. Law of conservation of energy, right? Mass and energy are related. Okay, you can convert mass into energy. Right. This reduced mass gets converted to energy. So this mass deficit becomes my binding energy. Okay, fine. To find this binding energy using this mass deficit, I need mass energy relation. Fine. This is our Einstein's very famous E equals mc square. Fine. This is my Einstein's equation. This is what it's all about. What you want to know now, 1 electron volt equals to 1.6 into 10 power minus 19 joules. Okay, and 1 joule is equal to, okay, I mean electron volt joule relation கிடைச்சிச்சு. Okay, ஒரு atomic mass unit 1 AMUக்கு 1 AMUக்கு energy release is 931 point something mega electron volts. Okay, I think it's 2 3 something, 931 mega electron volts and 931.5 mega electron volts. Okay, I'm really sorry. Okay, equal amount of energy is released for one atomic mass unit of for one atomic mass unit when it gets converted into energy to as a whole, this much amount of energy is released. Yeah, I think that's right. Okay, okay, fine. So binding energy, nucleus இருக்கு இல்லையா, my nucleus, அதான் நியூக்ளியஸோட individual particles இருக்கு இல்லையா, அதோட mass sum is more. Okay, mass sum ஒன்று, it's higher than the mass of nucleus. Okay, fine. This is my binding energy. Okay, this the deficiency, this mass deficit. Okay, I think I shouldn't have added this. Yeah, okay, this mass deficit is what enables binding energy. Okay, this is what makes the nucleus. It's very fascinating when you look into it. Okay, fine. So mass deficit, I told you. Nuclear force. Okay, when you see protons irka, protons illa da ottukana irukku in nucleus, how they are arranged in such a, but they don't repel each other, because after a particular distance, okay, after a particular distance there is a new type of force that starts to act. Okay, a new type of force starts to act. That new type of force is nothing but my nuclear force. Okay, this nuclear force, it acts, so lowering the potential energy. This graph you would have seen in mechanical properties of solids lab. Okay, in a graph enna solraduna potential, this is the y-axis is the potential energy and the x-axis is the distance between two particles. Okay, in our particular இடத்துல there is a low, it has lower potential energy, the least potential energy in the point irukku. Okay va, so basically what this graph is trying to say na, protons, okay, they repel, repel, and to when they come close enough in a particular, very after a very short range, they become, the force interaction between them becomes attractive. It's very strong as well, and this attraction overcomes the repulsion of electrostatic repulsion. Okay, fine, they attract. Okay, but when this attraction goes beyond and they go even closer, this exact nuclear force becomes repulsive, so the potential energy rises again. Okay, So it keeps, okay, in the nuclear force, keeps the proton, keeps the nucleons in a um, very specific distance. If it were too close, it'll repel. If it were too far, it'll attract. அவ்வளோதான் basically. Okay, fine. Around 10 power minus 15 meters this all this starts. Okay, இது வரைக்கும் ஓகேவா? Fine. இப்போ now let's see binding energy concept there is bro, it's what class? This is okay, wait. Binding energy, I'll tell you one thing. Binding energy is nothing but the amount of energy that's utilized from the mass of the nucleons for the formation of nucleus. Okay, இந்த பைண்டிங் எனர்ஜி வந்து எவ்வளோக்கு எவ்வளோ மாஸ் டெஃபிசிட் அதிகமாக இருக்கோ அவ்வளோக்கு அவ்வளோ நிறைய பைண்டிங் எனர்ஜி இருக்கும், அவ்வளோக்கு அவ்வளோ நியூக்ளியான்ஸ் ஸ்ட்ராங்காக, ஐ மீன் அவ்வளோக்கு அவ்வளோ நியூக்ளியஸ் ஸ்ட்ராங்காக இருக்கும். கரெக்டாக? ஓகே, we think that binding energy அதிகமாக இருக்க it will be more strong. But than just binding energy, what matters is binding energy per nucleon. ஒரு நியூக்ளியானுக்கு எவ்வளோ பைண்டிங் எனர்ஜி இருக்குன்ட்டு. Binding energy per nucleon, that's what matters. ஓகேவா? binding energy per nucleon தான் வந்து determines how much stable an atom is. Okay, fine. Stability of nucleus depends upon binding energy rather than binding energy per nucleon. Okay, fine. Paka, I think this is what actually matters. Fine. So there are two equations. இதை வச்சு தான் இந்த என்டையர் சாப்டரே ஓட்டாங்க. டென்சிட்டி, ஐ மீன் சைஸ் ஆஃப் நியூக்ளியஸ், மாஸ் எனர்ஜி ரிலேஷன், அதுக்கப்புறம் மாஸ் டெஃபிசிட் வச்சு வில் ஃபைண்ட் பைண்டிங் எனர்ஜி, அவ்வளோதான். தென் ஸ்டெபிலிட்டி ஆஃப் நியூக்ளியஸ் டிபெண்ட்ஸ் அப்பான் தீஸ் டூ ஃபேக்டர்ஸ் ஒன்லி. தி பைண்டிங் எனர்ஜி per nucleon, not just binding energy. Fine. Fine. Okay. Now just see, if I have an atom, if I have two atoms of say hydrogen and they fuse, okay, to form helium. Okay, இப்போ ஹீலியம்க்கு if it has lesser mass than that of hydrogen, can I say that some amount of energy would have been definitely released, right? Correct. That such reactions take place because the nucleus is unstable. Okay, as we progress through our periodic table, எப்படி இருக்குன்னா, we'll have a graph. Okay, a graph which gives the atomic number, this atomic number, and then this is the stability. Okay va, stability இப்படி இருக்கும். ஹைட்ரஜன், ஹீலியம், கொஞ்சம் மேலே போய் and then it will be going like this, something இந்த மாதிரி. ஓகேவா? இதில் வந்து மேக்ஸிமம் ஸ்டெபிலிட்டி இஸ் ஃபார் மை அயன். ஓகே, ferrous, it has maximum stability because it has maximum binding energy per nucleon, so that the nucleus is well held. ஓகேவா? இப்போ அதுக்கப்புறம் பார்த்தீங்கன்னா இட்ஸ் ஆல்மோஸ்ட் கான்ஸ்டன்ட் அண்ட் தென் தேர் இஸ் அ டிப் அதுக்கப்புறம் ஆஃப்டர் சம் டைம். ஓகே ஓகே ஃபைன். இப்போ நீங்கள் பார்த்தீங்கன்னா the the elements which are here, okay, before iron, they tend to become iron by combining, so they undergo fission, they undergo fusion, so that their nucleus gets even more stable. They want the stability. அதே வந்து இங்கே இருக்கு இல்லையா, இங்கே இருக்கிற ஹையர் அட்டாமிக் மாஸ் இருக்கிற எலிமெண்ட்ஸ்லாம் வந்து they also need more stability, so that they just break apart so that they can reach this amount of stability. So these elements, higher heavyweight elements, they undergo fission. They just break down. Okay, wow. Fission and fusion. Okay, fine. So this is what paves way to our nuclear fission, nuclear fusion reactions. Okay, fine. One thing you'll just remember, fusion reactions take place at high pressure and high temperature. Okay, fine. What do you see here? Okay, I'll give you an example for fission reaction. You'll be able to understand. Fine. Okay. I am having 2 kilograms of hydrogen, which combines to form helium, and I'm having 2 kg of uranium, which just breaks down into something, say xenon. I don't remember. Anna, which you teaching for all chapters is enough for NEET? Answer please. Yeah, this is enough for NEET. Then this teaching thing, it's better you solve questions. Okay. Ayan Hana. I don't know how to. I'm really sorry. Okay. Than this, it's better you solve questions on your own too. It will be helpful. Okay. Fine. Okay. Uranium, it underwent fission. Okay, it underwent fission. Helium produced on both the amount of energy was, for a one reaction, it was 26.7 mega electron volts, where 4 hydrogen atoms were involved. Okay, for a fission reaction, the amount of energy released was 200 mega electron volts. Okay, now we are supposed to find energy released in this fusion by energy released in fission. Okay, இப்போ hydrogen எப்படி helium ஆச்சுனா 4H1, they fuse to form 2 molecules of He. Correct? I think this makes total sense. ஆனால் இதுக்கப்புறம் you need you have 4 electrons here, you have 4 electrons there, you have you don't have neutrons here, you have neutrons here. Okay, this is what basically happens. Okay, 4 atoms fuse to form 2 molecules of helium, and with that, I mean, it's just one. No, they form 2 molecules of helium. I'm sorry. Okay, plus it gives above to 26.7 mega electron volt. Okay, fine. இப்போ ஒரு ரியாக்ஷன் இப்போ ஒரு 4 மாலிக்யூல் மட்டும் இவ்வளோ தருது. ஃபைன். 2 kg of molecules nothing but 4 ஆட்டம், அதாவது 2 மாலிக்யூல் இவ்வளோ தருது. அப்போது 2000 கிராம்ஸில் வந்து எவ்வளோ 2 moles இருக்கும்? I'll be having 800 moles. For 2 moles this much energy. For 800 moles it's 800 into 26.7 mega electron volts. Fine. Okay. அதுக்கப்புறம் யுரேனியமோட அட்டாமிக் மாஸ் இஸ் நத்திங் பட் 235. 235 கரெக்டா? இப்போ for one fission this is 200. So 200 into how many uranium atoms are there? 2000 divided by 235. Solve it and you will get the answer. Solve panna, you will get the ratio. This ratio, energy infusion by energy fission. Okay, fine. This is what it is. I'll definitely discuss more questions. Can I repeat this alone? Abhinav. Yeah, see, question on there, it's simple. Okay, wow. I'm having 2 kg of helium, 2 kg of hydrogen and 2 kg of uranium. Both are undergoing one fission, the fusion reaction. Fusion reaction, I know 4 hydrogen atoms are involved in making of 1 helium. So their masses are properly balanced. Okay, fine. And then I am giving, okay, adu one irukku, fine. And then over uranium, when it undergoes fission, I know the question is given that it releases 200 mega electron volts of energy. 26.7 mega electron volts of energy for 1 molecule of helium formation, or involving 4 atoms of hydrogen, or 2 moles of hydrogen molecules. Okay, it might be a little confusing. Simple terms tha. Okay, just remember. Okay, just try to understand. Okay, so ஒரு 4 mole of hydrogen atom க்கு 26.7 mega electron volts na 2000 கிராம்ல எத்தனை 4 mole of hydrogen atoms இருக்கும்? It will be 2000 divided by 4. It will be 500. Right, இங்கே தப்பா போட்டிருக்கேன். This is 1000. It will be 500. Okay, so 500 molecules of hydrogen, molecules of 500 hydrogen atoms reactions can, 500 times this reaction can undergo. Okay, this reaction to produce this one, it can take place 500 times. Okay, fine. Now for this exact same thing, now it's in the reaction it's 2000 divided by 235 அத்தனை moles of uranium இருக்கு, into multiplied with Avogadro number here as well. Both will get cancelled, so it's not necessary. We are finding the ratio, so it's easier கண்டுபிடிச்சலாம். Okay, fine. It's a little numerical based question konjam. நீட்டில் பெருசாக கேட்காம ஐ ஜஸ்ட் வாண்டட் டு ஆஸ்க் திஸ். ஏன்னா இது வந்து நான் ஜேஇ மெயின்ஸ் எழுதும் போது எனக்கு இந்த கொஷின் கேட்டிருந்தாங்க. இட் வாஸ் இன் மை எக்ஸாக்ட் சேம் ஷிஃப்ட், April 9th, second shift, 2024. So I thought this will be helpful. It's a little calculative, okay? அதில் வந்து they are focused on all this decimal points எல்லாம். So we can't right? ஓகே, வேறு டவுட்ஸ் இருக்கா? அண்ணா யூஆர் ஜேஇ ஆஸ்பிரண்டா? ஐ ரோட் ஜேஇ, அவ்வளோதான். வா. ஸோ யா, ஸோ ஐ திங்க் இதோட முடிஞ்சு திஸ் சாப்டர். ஆல் தியரி பேஸ்ட் கொஷின். ஐ நீட் டு சால்வ் கொஷின்ஸ். கொஷினுக்கு தனியாக இருக்குது, மாடர்ன் ஃபிசிக்ஸ்க்கு தனியாக ஒரு செஷன் இருக்குது. ஐ வில் டெஃபினெட்லி இன்க்ளூட் குட் குவாலிட்டி கொஷின்ஸ் அதில். ஓகே, ஃபைன். ஸோ இதோட முடிச்சுக்கலாம் கிளாஸ். ஃபைன், ஓகே. இன்னைக்கு ஈவினிங் ஒரு கிளாஸ் இருக்கும், மேக்னடிசம் அண்ட் மேட்டரில். இட்ஸ் ஆல்சோ அ தியரி பேஸ்ட் தியரி, ஃபுல் ஆன் தியரி சாப்டர். ஐ ட்ரை டு மேக் இட் இன்ட்ரெஸ்டிங். ஆனால் அந்த தியரி கொஞ்சம் கன்ஃபியூசிங்காக இருக்கும். சசெப்டபிலிட்டி and all those things. I'll make it easier for you guys. If you have any help, if you want any help in your preparation, 24 days தான் இருக்குது, 23 days இந்த மாதிரி இருந்தாலும் லெட் மீ நோ இந்த காமெண்ட்ஸ். இல்லை கிளாஸ் அப்போ கேளுங்க, பர்சனலாக இன்ஸ்டாகிராம் இல்லை வாட்ஸ்அப் நம்பர் இருந்துச்சுன்னா, மெயில், எனி திங். ஐ ட்ரை டு பி ஆக்டிவ் இன் every single platform. So yeah, thank you. Okay, this class might have been a bit dry. எனக்கே ட்ரையாக தான் இருந்துச்சு, because I didn't solve any questions. அதான், there is, again I'm telling you, there is a very well dedicated question solving session for entire physics. ஒரு 4 செஷன் இருக்கு. அதில் வந்து one part for modern physics I'll include everything. Yeah, mostly reaction based question will come, or they'll simply, or they might simply ask the radius of nucleus of this atom and that atom ratio. அந்த மாதிரி கேட்கலாம். If they wanted to ask difficult in a difficult way na, it will be because it will be from beta decay, fission fusion reactions and all. Okay, I will அதான் question solve பண்ணும்போது it will be included, don't worry. Fine. Okay, alright guys, see you in the next lecture இன்னைக்கு evening. Okay, probably around 6:30. Yeah, 6:30 or 6:30. Fine, okay, thank you so much. $6:30 or 7, because I have a little work to do evening college போய், then I think 6:30க்கு வந்துடும்னு நினைக்கிறேன். 6:30 or 7. Okay, Bye, everyone.